Welcome. This video is going to be about the atmosphere and the clouds on our giant planets. So now we are in section 11.3, thinking about atmosphere. We're going to not go into all the details about the layers of the atmosphere and things like that, but we are going to talk about clouds. Clouds on Jupiter and on some of the other giants, because I want to just think about what it would be like if you were in that thick gas atmosphere. What do we see from the outside? Those kind of things. So we look at Jupiter and we see clouds covering the whole planet. That's not like a surface being dark red and orange and things. Those are clouds. And we see stripes, right? Those stripes are called bands. So you have strong, dark, and light bands. These bands are sometimes also known as belts and zones, but I'm going to use the sort of more generic term bands. And you see that here, right? You see dark and light and dark and light making these stripes on the planet. And that's caused by strong winds. You got a really fast moving planet, it's all gas, and it has winds. Even though there's no surface, there's wind within these gas layers in the atmosphere. So these strong dark and light bands on the surface are caused by winds that go in opposite directions, caused by east and west winds. Okay, that alternate up and down, caused by east and west alternating winds. And I don't know which is which, but the idea is here, if this layer is going this way, then the next layer is going the other way. And you alternate every time there's a stripe on the planet. And you get this really cool, interesting pattern, swirly things. Think about it as storms, storm clouds and windstorms and all of that swirling around in the thick atmosphere of Jupiter. There is, of course, one storm that many of us have seen before, and that is the extremely long-lasting storm called the Great Red Spot. So Jupiter has the Great Red Spot, and it is a long lasting giant storm. Since we're not in person, I can't give you bad jokes for your clicker questions, but I have to tell you this one anyway. So what does Jupiter name his big red dog? Spot, right? Okay. Anyway, this spot is really interesting, the Great Red Spot, because it's huge, for one thing. It is bigger than Earth. A few years ago, I would have said it's bigger than twice Earth. 2 Earths could fit inside of it, but we've realized in recent years that it's shrinking. So it's bigger than Earth, but shrinking. Not very fast. It's just not quite as big as 2 Earths anymore. It has been around an extremely long time. It is at least 300 years old, because that was our first report. With a decent telescope on a dark night, good conditions, you can see the spot. So it was first reported about 300 years ago, shortly after telescopes were invented. But it hasn't been the same. We said it's shrinking. It's also, I'm going to give myself more space here, it is also varying. It varies with time in size, we said that already, but also in color. It gets darker or lighter, and sort of the internal swirlies, the motions that you see inside of it. The other weird thing about it, especially for those of us that are familiar with hurricanes, this isn't exactly like a hurricane because it swirls in the opposite direction. That means that this is not a low pressure storm like a hurricane, but a high pressure storm. On Earth, high pressure usually means good weather, fair weather, and low pressure is our storms. But this is a high pressure storm because it swirls in the wrong direction, which is kind of interesting to think about. So I'm going to post a video after this one about some of the most recent data about the Great Red Spot. And one of the things it said is not only it's shrinking, but it's surprisingly deep. It goes very deep into the atmosphere, and that might be part of why it's lasted such a long time. So check out that video after you watch this one. Moving from Jupiter, we see clouds on Saturn as well. Saturn is just like the more subtle version of Jupiter, that there are still bands there, but they're more subdued in color and width and things like that. But you do see a similar band structure in the clouds. So if we see the band structure, it tells us there's winds, right? Similar band structure to Jupiter. And if we see that, we know that there are east-west winds. Okay, same reason, because of winds. But they're different color, right? We don't see the bright reds and the oranges. So that tells us we have different stuff there. Different materials, different chemistry is going on in those layers to get these sort of prettier pastels than we saw on Jupiter. On Jupiter, we see the Great Red Spot, but we also see other big whirling, spiraling storms. On Saturn, that's rarer. That's not as common. We don't see individual clouds and storms as often. So individual clouds, that's an L, clouds and storms are more rare than we saw with Jupiter. And so you often see this looks like a smoother surface. We have found, though, that if we look at the poles, we see more swirls and more storms up at the poles. So check out this picture. This is closer to the pole. If you look at some recent pictures online from way up at the top of the poles, you see similar things. But this is a big storm. And this doesn't happen that often, but occasionally we see it. And the cool thing is that they're not completely different than storms on Earth. Not rain, probably in the same way, although there might be some kind of weird thing going on there, but they are very violent, and we see lightning. So that's really kind of cool that you get electrical charges, cloud-to-cloud lightning on a different planet. So on Saturn, we see violent lightning-producing storms. So these storms are all about wind. You can get this electricity crackling through the clouds. Not really sure if there's precipitation. Might be some kind of thing going on there. Wouldn't be water. Would look very different from what we see here. So there's another very short video that talks about some of the lightning on Saturn. If you're interested, that's in the playlist as well. And last but not least, we do see clouds and storms sometimes as well on Uranus and Neptune. So clouds, on Uranus and Neptune. Uranus is a little more rare, but we see them occasionally. So pictures here, Uranus is on the top, Neptune is on the bottom. This picture of Uranus was taken in the infrared so that you can see the rings. We're going to talk about the rings of the planets, but Uranus does have rings, and the infrared also highlights some of the clouds and storms, as well as sort of the band structure that we see on the other planets as well. So these planets do have weak banding. They still have very high winds. That's part of how these planets are, just windy, windy, windy all the time. We see clouds show up not always dark, but sometimes white, like we imagine and we see here on Earth. So we have on these planets often small, bright, whitish clouds or darker clouds. And sometimes they're not huge swirly storms, but they're just these little things, right? And then we do see larger storms. This is an older image of the Great Dark Spot on Neptune. So you do get some large storms, but they don't stick around. We don't have a 300-year storm like we saw on Jupiter. So that's just one example, is the Great Dark Spot on Neptune. It only lasted for a few years. We don't always have telescopes pointing at Neptune, but we looked for a little while. Later we looked again, and it was gone. So the Great Dark Spot on Neptune, comparison to Jupiter, lasted about 5 years. And there have been others since then, since that one disappeared. Other storms have popped up on Neptune, but they never last for very long. So different stuff going on there, but I just wanted to do some compare and contrast between those planets and what their atmospheres are like. When we come back to class, we're going to be diving into those interiors, talking about what's inside. Here's one last clicker question that'll be on Moodle for you. And that is the end of this video. Y'all have a good one.